Application of the QAF checklist. Weight of evidence evaluations for Ames mutagenicity of 2-heptanol. Thank you for the opportunity to present this case study. We have used the QAF checklist to evaluate 2 QSAR models and 2 predictions using the model and result checklist. This is a weight of evidence approach where we have combined experimental data from 2-heptanol, its close analogues, and QSAR predictions from OASIS Times and DEREK nexus. First, I will introduce the chemical we are assessing. Then I will give an overview of the available experimental data. And following that, I will go through the model checklist and I will focus on unfulfilled assessment elements. I will also go through the prediction checklist with a focus on elements with moderate or high uncertainty. Finally, I will provide some conclusions using the result checklist. 2-heptanol is an aldehyde that was assessed by AICIS in a group evaluation. Limited point mutation data was available for 2-heptanol as well as for structurally similar chemicals. 2-heptanol was negative in the strain TA104 and the results in the strain TA100 were unclear. Here is an overview of the available data for 2-heptanol and closely related 2-hexanol and 2-octanol. To simplify the presentation, we have limited our discussion to Ames mutagenicity without metabolic activation. This is because the majority of the data was for mutagenicity without metabolic activation. Furthermore, there were no alerts for DNA binding for simulated S9 metabolites of 2-heptanol in the OECD toolbox. As you can see, the results in TA100 are unclear. They are contradictory in TA104, and only 2-hexanol has data for the other strains. The QAF checklist. The model checklist enables a systematic assessment of a QSAR model. It consists of assessment elements to evaluate a model according to the OECD QSAR principles. It also contains instructions how to map QMRF information to the checklist. The result checklist is used when assessing multiple predictions, and it establishes whether the model's input is correct, the substance is within the applicability domain, the predictions are reliable, the outcome is fit for a regulatory purpose. It also establishes uncertainty of the predictions. OASIS Times model checklist. All assessment elements were fulfilled apart from 4.1, goodness of fit, robustness, and 4.2, predictivity. The reasons for not fulfilling the above assessment elements were that statistic cross-validation was not performed and the full training set was not available. There was also no external validation available. In this example, predictions were used in combination with other in silico predictions and experimental data in the weight of evidence approach. The mechanistic basis of the model allows us to assess the reliability of individual predictions even in the absence of comprehensive information on the global performance of the model. Therefore, we consider the model valid for its purpose. DEREK Nexus model checklist. All assessment elements were fulfilled apart from 1.2, transparency of the underlying experimental data, 4.1, goodness of fit, robustness, and 4.2, predictivity. The reasons for not fulfilling these assessment elements were that the data for each descriptor variable or dependent variable for the training set were not available, and the training set was not available. According to the QMRF, external validation is carried out on each knowledge base release. However, the curated datasets used at LASA are proprietary. In this example, DEREK predictions were used in combination with other in silico predictions and experimental data in the weight of evidence approach. Therefore, the model documentation is considered sufficient for assessing the validity of individual predictions with the prediction checklist. While the curated training set is not available, the mechanistic basis of the model allows us to assess the reliability of its individual predictions even in the absence of more comprehensive information on the dataset used to create this expert rule-based model. And also each prediction is supported by publicly available references. OASIS Times Prediction Checklist. OASIS Times predicted 2-heptanol to be negative for Ames mutagenicity. The prediction was in domain. Each assessment element in the prediction checklist is assigned an uncertainty. I will not discuss the assessment elements with low uncertainty. Assessment element 1.3, reliable input parameters, was assigned medium uncertainty because smiles was the only input. Assessment element 3.1, reproducibility, was assigned medium uncertainty because we have not tried predictions with another version of OASIS Times. For assessment element 3.2, overall performance of the model, was assigned medium uncertainty because performance of the model was only reported for the internal training set. Assessment element 3.4, performance of the model for similar substances, was assigned medium uncertainty. While we got the same prediction for 2-hexanol and 2-octanol, experimental data for those chemicals are limited. Assessment element 4.1 to 4.3, outcome is fit for the regulatory purpose, was not assessed because we were not using the prediction as a standalone result. We found this prediction acceptable for its intended purpose with an overall uncertainty medium. QSAR was used as weight of evidence. We compared test data for the chemical and its analogues with QSAR predictions. Therefore, although assessment elements 4.1, 4.2 and 4.3 are not fulfilled, the prediction was considered acceptable to use in weight of evidence determination. DEREK Nexus Prediction Checklist. DEREK Nexus predicted 2-heptanol to be positive for Ames mutagenicity. The reasoning level was plausible. Assessment element 2.1, substance within the applicability domain, was assigned medium uncertainty because the structural activity relationships describing the mutagenicity are defined by the developer to be the applicability domain for the model. Therefore, if a chemical activates an alert describing a structural activity for mutagenicity, it can be considered as being within the applicability domain. Assessment element 3.1, reproducibility, was assigned medium uncertainty because we have not tried a prediction with another version of DEREK Nexus. Assessment element 3.2, overall performance of the model, was assigned medium uncertainty because the overall performance on the model could not be assessed since it is an expert model. Assessment element 3.3, fit within the physicochemical, structural and response basis of the training set of the model, was not assessed because the training set is not available. Assessment element 4.1 to 4.3, outcome fit for regulatory purpose. We did not assess this, and this was because we were not using the prediction as a standalone result. We assessed this prediction to be acceptable for its intended purpose with an uncertainty of medium. And this is because QSAR was used as weight of evidence, and we compared test data for the chemical and its analogues with QSAR predictions. Therefore, although assessment elements 4.1, 4.2 and 4.3 were not fulfilled, the prediction was considered acceptable. Conclusion on the final result. Despite the contradictory result from the two different models, we concluded that the results were acceptable for its intended purpose. As a freestanding outcome, without experimental data to compare, these QSAR results may not have been acceptable for hazard conclusions. However, as the QSAR predictions were conducted to compare it with test data, in weight of evidence assessment, this QSAR result is considered acceptable for its intended purpose. Expert judgment was used to assess the outcomes of the predictions. And the reason for the conflicting prediction results may be due to bacterial strain-dependent mutagenicity. Comment on the final result. Both DEREK Nexus and TIMES models identify the same alerting group, alpha-beta unsaturated aldehydes. The two models gave contradictory predictions for the Ames assay without metabolic activation. The in vitro mutagenicity test data available for the chemical and other alpha-beta unsaturated aldehydes also reported contradictory results. Conclusion on Ames mutagenicity. Here we have summarized experimental data and QSAR predictions for alpha-beta unsaturated aldehydes. As you can see, the experimental data indicate that mutagenicity in the aldehydes is strain-dependent and mixed. Therefore, it's not surprising that the two QSAR models give conflicting results. Thank you for listening to our presentation. Please see the QAF Excel spreadsheets for further details.